red dotted lines. Now, so the idea here is for this circle, okay, the total amount of current passing through this circle is going to be equal to, there are n terms, okay, n loops. So n into I naught, capital N into I naught will be the total current passing through this circular path or inside this circular path. Is that okay? Or applying Ampere circuital law. Okay.
Okay.
Uh, total current passing through the circle, red dotted circle, red dotted circle will be n into I naught, that is n I naught applying Ampere circuital law. We have B vector dot dl vector line integral is equal to mu naught into total current. I is equal to Ni naught. This will become mu naught into capital N I naught. Okay. This number might be taken as small n. And this small n is nothing but number of loops per unit length and number of turns per unit length. So I is replaced with Ni naught, the total current passing through the circular loop. B and dl. B vector and dl vectors. How are they going to be related? B vector is going to be either into the plane or out of the plane at this point. Okay. Into the plane or out of the plane. Therefore, B and D are going to be B and DL are going to be along same direction or along opposite direction. In either of the cases, B dot DL will become B DL cos theta or theta will be either 0 or 180. 0 या 180 के basis पर up the plane and down the plane into the plane वो चीज decide होगा, but it is going to be BDL. The magnitude is going to be BDL. So B vector dot DL vector is eventually going to be BDL as angle between B vector and dl vector is 0 degree. Therefore, b vector dot dl vector is equal to b dl. So this b dl is equal to mu naught n I naught. B will be B is going to be a constant number because it is a symmetric figure. हर तरफ से एक ही जैसा है, तो यहाँ पर जो भी b की वैल्यू रहेगी दैट इज गोइंग टू बी कांस्टेंट वैल्यू. कांस्टेंट है तो इंटीग्रल से बाहर निकाल लेंगे एंड इट विल बिकम b इंटीग्रल. अच्छा, दिस integral with this circle sign is called line integral. Line integral along the circumference we have to integrate. So along the circumference, whatever the circumference look like, so it has to be integrated along the entire circumference or whatever figure it given. यहाँ पर circle है, so line integral of dl will become equal to b into 2 pi a, and this will be equal to mu naught n I naught. इसको राइट साइड में लेकर के आते हैं तो इट विल बिकम b विल बी इक्वल टू म्यू नॉट कैपिटल N I नॉट कैपिटल N I नॉट divided by 2 pi a. ठीक है, this can also be written as mu naught small n into I naught, where small n is equal to number of turns plus loops per unit length. ठीक है, so this is how it is going to be this. अच्छा, away from मतलब outside the toroid, outside the toroid, if I am crossing over this boundary, यहाँ पर अगर हम देखने की कोशिश करेंगे तो there will be zero magnetic, there won't be any magnetic field, क्योंकि यहाँ के किसी भी एरिया में there is no current which is passing. It will be there only inside the core of the toroid and there won't be anything outside.
सरफेस पे होगा क्या लेकिन?
सरफेस पे एज इन यहाँ पे ना,
हाँ हाँ होगा.
हाँ सरफेस पे रहेगा. इनसाइड द कोर मतलब बिटवीन दिस बाउंड्री टू दिस, बियॉन्ड
तो
दैट. सॉरी,
सरफेस पे भी नहीं होगा ना मतलब सर?
आर यू टॉकिंग अबाउट द नेट सर, ये वाला सरफेस ना?
हाँ वो सरकमफ्रेंस उसका.
दिस पॉइंट राइट, दिस बाउंड्री राइट.
हाँ हाँ
हाँ, यहाँ पर रहेगा, इसके बियॉन्ड नहीं रहेगा, बेसिकली इन वायरिंग्स के बियॉन्ड नहीं रहेगा.
ठीक है.
इज दैट ओके?
यस.
ओके, So the key idea over here is ये जो black and region है ना, black वाला region, the magnetic field is going to be there only. Outside it, even यहाँ पर अगर हम देखते हैं Q point और इधर मान लो कोई R point लेते हैं, ना R पे कोई magnetic field रहेगा ना Q पे magnetic field रहेगा. It is only going to be in this black portion. ठीक है?
हाँ सर।
We may draw a few graphs to understand these. I mean, to express the derivations. I'm just giving the final values for few things. Okay. Special references. Magnetic field due to cylindrical current carrying wire. इसमें तीन conditions हैं. पहला, within wire, such that R is less than capital R. For this, B happens to be equal to mu naught by 2 mu naught into 4 pi. Q mu naught into 4 pi or just mu naught by 2 pi into I R upon R square. ठीक है? R is the distance from center जहाँ पे हम explore कर रहे हैं. So it could be like this. ये current carrying wire है. ठीक है? This is current carrying wire. I may paint it blue. This is current carrying wire. ठीक है? And current is going like this. इस डायरेक्शन में करंट जा रहा है. This is the axis of the wire and we are looking at a point, this maybe P, at a distance small r, where radius of the wire is capital R. ठीक है? Second point will be at the surface. If we are looking at a point maybe Q on the surface of wire, and then we are looking at a point maybe S outside the boundary of wire. ठीक है? तो इसके लिए ये रहा within the wire, R less than R. It is point P at point within the wire, R less than capital R. ठीक है? The field is going to be like this. B is at point P Oh, sorry, at point Q on the surface of wire R is equal to capital R. B happens to be equal to 2 mu naught by 4 pi I upon capital. तो ये R की वैल्यू कैपिटल R हो जाएगी, कैपिटल R, और ये नीचे का एक कैपिटल R विल गेट कैंसिल, दूसरा वाला कैपिटल R बचा रहेगा. आउटसाइड C at point S, outside the wire, R is greater than capital R and B becomes equal to 2 mu naught 4 pi I upon small r. Now, how is the graph going to look like for all these three? It is going to look something like this. There might be this y-axis. This might be capital R distance. This will be capital R distance from left and right side. It is going to look like up to R, a straight line. Similar straight line here as well, till the boundary of the the circular cylindrical wire, up till the boundary. Boundary के बाद क्या हो जाएगा? It is going to decay, and the decay curve is going to look like hyperbolic decay curve. Is that okay? B into R, they are going to be, बाकी चीजें जो है वो constant है, mu naught 4 pi and I all are constant. B into R is going to be a constant. So that is going to decay as a hyperbolic curve. ठीक है, ये हो गया सेंटर 0. ये वाला axis की बात कर रहे हैं, the axis is lying at this point, and then this is the outer boundary of the wire on the left side and on the right side. Initial variation is proportional and a straight line, and then there is a hyperbolic form. ठीक है. The second scenario, this was sort of solid cylindrical current carrying magnetic field due to solid cylindrical current carrying solid cylindrical magnetic field due to cylindrical hollow cylindrical due to hollow cylindrical current forming wire. इसमें भी तीन conditions. The wire may be looking like this. ठीक है. This will be the axis of wire. Internal point, surface point. So this is P, this is Q, and this may be S. P per field, Q per field, and ये capital R है. This is ये distance of P, distance of Q, distance of S is, in all cases it is R. R may be less than capital R, equal to capital R, or greater than capital. At point P for R less than capital R. Now this time B is going to look like 0, B at point Q for small r equal to capital R, and this time B is going to be equal to B is equal to 2 mu naught by 4 pi into I upon capital R. P at point S for R greater than capital R. B is equal to 2 mu naught by 4 pi I upon small r. The graph is going to look like so. Everywhere less than r minus r to plus r. It is going to be like this, and then there is parabolic form, right? So the graph is going to look like this. Next one is magnetic field at solenoid. इसके ग्राफ्स हमने ऑलरेडी पिछले बार में देख लिए हैं लास्ट वाले में. टोरॉइडल जो है इसका ग्राफ जो है दैट इज magnetic field within the core of toroidal. The graph happens to look like this is the center line, in marking internal radius, external radius. So this might be internal radius A, external radius. So toroid जो है हमारा that is going to look something like this. Is that okay? यहाँ पर center से this radius happens to be A and this radius happens to be B. The graph is going to look like so. Then there is going to be exponential, sorry, parabolic decay, but it will not be decaying to the very low value. It will just fall down like this swiftly and will stop at a substantive value. ठीक है? This is how the graph of magnetic field between A to B looks like. Okay. Next discussion in magnetic field is uh, there are two things. One thing is if we have like there is a magnetic field and we have a current carrying wire being brought into that magnetic field. So basically, there is some magnetic field which is already existing. North to south, they are going. South to north, they are going. Okay. And so this is magnetic field which is already there, and we have a current carrying wire being present, which is not aligned along the direction, rather perpendicular to the direction of magnetic. So this current carrying wire is going to experience a force on it. ठीक है, और this current carrying wire experience a force on that expression for that force is something we are going to discuss now. Apart from that, suppose हमारे पास current नहीं है, current carrying wire नहीं है, rather there is a electron or a proton or a positive ion, ठीक है, that is basically moving along this direction, and there is a this magnetic field which is already exists. ठीक है, तो अगर इलेक्ट्रॉन मूव कर रहा है, that means some current is flowing. Obviously the direction of current is going to be opposite to the direction of flow of electron. प्रोटॉन अगर फॉरवर्ड डायरेक्शन में जा रहा है तो करंट हमारा फॉरवर्ड डायरेक्शन में जा रहा है, पॉजिटिव चार्ज अगर फॉरवर्ड डायरेक्शन में जा रहा है तो करंट हमारा फॉरवर्ड डायरेक्शन में, राइट? नाउ दीज थिंग्स, the movement of these entities, that is electrons or negatively charged ions or proton or positively charged ions, each of them is going to have same effect as current carrying wire. Am I making sense? And therefore, like the current carrying wire, they are also going to experience the force because of this magnetic field. Are we getting this point? ये बात समझ में आ रही है?
हाँ सर.
What I am trying to say?
Yes sir. Yes sir.
Yes,
I'm
sir.
just trying to say there is already existent magnetic field, and this magnetic field might be because of a magnet or might be because of another current carrying wire. ठीक है, इसके प्रेजेंस में अगर किसी इलेक्ट्रॉन को, मतलब इस वाले करंट की वजह से दिस मैग्नेटिक फील्ड हैज बीन जनरेटेड, एंड and under influence of this magnetic field, if we have a another wire placed near to it, or the magnetic field of first wire, wire 1, there is present some wire 2, or any of these particles moving in a straight line, ठीक है, their movement is going to have a current, presence of a current, and that current or this current carrying wire is going, it will be experiencing a force on them. Making sense? So every magnetic
Yes
field,
sir.
if there is a current in its vicinity, I mean, if at all there is a magnetic field and a current is being flown through it or being passed through it, or a current carrying wire is placed in influence of that magnetic field, that current carrying wire or the source of current or current carrier is going to experience a force on it. Now, that force is given by, that force is explained or given by, in case of wire, it is simply F force is equal to BIL. Yeah, IL cross B, L cross B होता है, ठीक है? So we have two formulas which we are going to concentrate on. पहले हम लोग लेंगे, okay. So magnetic force due to a magnetic field. इसमें A है magnetic force on charge on a moving charge. Okay. This is simply the magnetic force. It is indicated by FB vector. It is equal to, if the charge is Q and it is moving with velocity V vector, then F vector is equal to QV vector into B vector. That is how this is given as. Magnetic force is equal to Q times V cross B. V is velocity with which charge is traveling. V vector, velocity at which velocity at which charge Q is dropping. ठीक है, इसमें आइडिया क्या है, V का डायरेक्शन जो होगा और B का जो डायरेक्शन होगा, इन दोनों के डायरेक्शन या इन दोनों वेक्टर्स के प्लेन के परपेंडिकुलर हमारा F वेक्टर रहेगा. सो द आइडिया हियर इज, एंड V को हमको किधर टर्न करना है, अराउंड B. ठीक है ना, मान लो ये V वेक्टर है और ये B वेक्टर है. So V has to be turned towards B, keeping our palm on B and turning it around B or towards B. And in that case, our thumb will be pointing in this direction and this will be the direction of F. Is that okay? This can also.
Yes, sir.
So what we are doing, we are keeping V palm or these fingers along V vector, turning it towards B, and the thumb is pointing towards myself. So this is the direction of force. Actually, this is also explained through Fleming's left hand rule. ठीक है, इसमें B vector happens to be the magnetic field vector. Velocity is, or this is the direction of current or velocity of charge. ठीक है, this is B vector, this is V vector, and this is the direction in which the force will be experienced by the charge. ठीक है, या करंट कैरिंग वायर अगर इस डायरेक्शन में लेटा रहेगा तो उस पर फोर्स किस डायरेक्शन में रहेगा, इस डायरेक्शन. इज दैट ओके? चार्ज अगर इस डायरेक्शन में मूव कर रहा है तो फोर्स किस डायरेक्शन में रहेगा, इसी डायरेक्शन. मेकिंग सेंस?
Yes, sir.
Okay. So this is given by, this is called Fleming's left hand rule. This is called index finger. Index finger is going to indicate what? Index finger indicates magnetic field. Middle finger indicates
Current.
velocity vector of the charge or the current direction of current carrying wire or direction of current in the wire. ठीक है, and the thumb represents the force experienced on the charge or the wire.
Okay.
Is that okay?
Yes, sir.
So I'll just explain this Fleming's left hand rule. Fleming's left hand rule. Index finger B vector, middle finger V vector or L vector, thumb is equal to FB vector. ठीक है? अच्छा, यहां पर नोटिस करने वाली बात क्या है? द फोर्स एक्टिंग ऑन द चार्ज, ठीक है, जिस डायरेक्शन में भी ये चलेगा, ठीक है, उसके परपेंडिकुलर इस पर फोर्स लग रहा है। बात समझ में आ रही है? ये जिस डायरेक्शन में भी मूव कर रहा होगा, जैसे अभी ये मान लो एक्स एक्सिस है, एक्स एक्सिस के अलॉन्ग मूव कर रहा है, ये वाई एक्सिस, तो इस पर फोर्स किधर लग रहा है? जेड एक्सिस के अलॉन्ग। इज दैट ओके?
यस सर।
और जेड एक्सिस के डायरेक्शन में फोर्स लगने की वजह से होगा क्या? इसका पाथ जो है दैट विल इवेंचुअली बिकम सर्कुलर। ठीक है? क्योंकि इट इज द सर्कुलर मोशन ओनली जहां पर फोर्स इज ऑलवेज परपेंडिकुलर टू द वेलोसिटी वेक्टर। ठीक है? फॉर एग्जाम्पल जस्ट समझने के लिए समझो, यहाँ पर यहाँ से इस पर फोर्स इस डायरेक्शन में लगा, जिसकी वजह से ये थोड़ा थोड़ा मुड़ता हुआ यहाँ पर आया। अभी वेलोसिटी वेक्टर किधर रहेगा? इस डायरेक्शन में रहेगा। एक्सजेड प्लेन में घूम रहा है ना। तो जब ये यहाँ पर आएगा तो फोर्स हमारा इस डायरेक्शन में जाने लगेगा। जब ये यहाँ पर आएगा तो फोर्स इस डायरेक्शन में हो जाएगा। जब ये यहाँ पर आएगा फोर्स इस डायरेक्शन में हो जाएगा। फिर यहाँ पर आएगा तो फोर्स इस डायरेक्शन में हो जाएगा। बात समझ में आ रही है? यू कैन जस्ट यहाँ से चालू करते हैं, इस जगह से। अभी
हाँ।
यहाँ तो हर टाइम पे फोर्स का डायरेक्शन देखते जाओ। इट इज ऑलवेज गोइंग टू बी लाइक दिस ओनली, पॉइंटिंग टुवर्ड्स द सेंटर। सो चार्ज जो है, मूविंग चार्ज इज ऑलवेज गोइंग टू एक्सपीरियंस a force which will be perpendicular to the direction of its velocity. ठीक है? और perpendicular force जब भी होगा, that is always going to create a circular motion and it will not lead to increase in the velocity of the particle, right? It will not lead to increase in speed of the particle. ठीक है? स्पीड तभी इंक्रीज करती है जब वेलोसिटी वेक्टर या स्पीड के डायरेक्शन में, मोशन के डायरेक्शन में फोर्स लगता है। ये बात समझ में आ रही है? एनी प्रॉब्लम?
नो सर।
ठीक। द फोर्स, अच्छा बाकी के केसेस ना मैं कल के लेक्चर में फिर डिस्कस करूंगा। कल वो
कल
3,
कितने बजे होगा?
कल 3:30 के अबाउट अराउंड लूंगा।
ओके सर।
ठीक है? और कल ऑनलाइन ही लूंगा, यहाँ पे नहीं रहूंगा, इसलिए कल ऑनलाइन ही लूंगा। यू कैन
हाँ सर, ठीक है।
द फोर्स ऑन the charge on the moving charge on the moving charge will always be perpendicular to the direction of velocity of the charge. Therefore, this force will only change direction, change the direction of the motion of moving charge and increase or decrease and further, if everything is not perpendicular, that means b vector and velocity vectors are not perpendicular, then fb will simply be equal to q v b sine theta. Sine theta is the angle between v vector and b. Theta is angle between v vector and b vector. Is that okay? ये बात समझ में आ रही है? अगला एक चीज छोटा सा होता है. This is the force which is experienced by the moving charge. ठीक है? और moving charge is going to transverse a circular motion, right? यहाँ पे अगला पॉइंट हमको जानना होता है. As the charge is experiencing a force which is always perpendicular to direction of motion of charge. Hence, the charge will undergo circular motion. ठीक है? और सर्कुलर मोशन में सेंट्रीपिटल फोर्स विल बी इक्वल टू सर्कुलर मोशन. Therefore, centripetal force on charge is equal to magnetic force on charge. This further implies सेंट्रीपिटल फोर्स क्या हो जाएगा, मास ऑफ द चार्ज, ठीक है, into velocity square of the charge divided by r, radius of the circular path, radius of circular path, v, velocity, rather I should call it speed, not velocity, speed of moving charge, mass of the charge, m. This is equal to Fv, which is equal to Q V P sin theta. Is that okay? V cancel हो गया. R will be equal to mv divided by qb sin theta. Are we getting this point?
ठीक, हाँ सर.
ठीक है ना. सो ये रेडियस हम पता कर सकते हैं. और इसमें एक छोटी सी चीज है, mv is momentum, so this would also be written as mod p vector momentum vector upon q b sin theta. अच्छा, f is equal to q v b sin theta के टर्म्स में हम b को टेक्निकली या यूनिट ऑफ मैग्नेटिक फील्ड इज वेबर पर मीटर स्क्वायर या टेस्ला. मैग्नेटिक फील्ड का यूनिट जो होता है दैट इज टेस्ला और वेबर पर मीटर स्क्वायर. यूनिट ऑफ मैग्नेटिक field is Weber WB per meter square. So it's WB per meter square, Weber per meter square और टेस्ला कैपिटल. ठीक है, और इसको हम लोग with the help of the new definition or new relationship b is equal to f upon q v sin theta. ठीक है, so theta can be taken as 90 degree. Magnetic field of 1 Tesla or 1 Weber per meter square is said to be acting if 1 Newton of force is experienced by charge having or charge of 1 coulomb moving with 1 meter per second. Is that okay? And its motion is such that it is perpendicular to the field. Then we say that magnetic field is 1 Tesla or 1 Weber per meter square. सबकी वैल्यू 111 हो जाएगी, तो B is going to be equal to 1, right? Are we getting this point?
हाँ सर.
ठीक है, ठीक है. आज के लिए हम
सर वो लास्ट वाला वापस बोलोगे?
क्या क्या, सॉरी.
1
हाँ, 1 टेस्ला और 1 Weber per meter square magnetic field is said to be applied if a charge of 1 coulomb is moving with 1 meter per second, perpendicular to the direction of magnetic field. Perpendicular to the direction of magnetic field. Experiences 1 Newton force. ठीक है? So a magnetic field of 1 Tesla or 1 Weber is said to be applied on a charge if the charge of 1 coulomb is moving with 1 meter per second, and that too perpendicular to the direction of magnetic field, and is experiencing a force of 1 Newton on it. Okay? Then we say that the magnetic field which is acting is 1 Weber per meter square or 1 Tesla. Making sense?
Yes, sir.
sir.
Okay. So we will stop here for today. Kal ke din we will again take it forward.
Okay.
Okay, sir.
Bye for now.